Thank you very much for sharing the work we're currently busy with you today. As mentioned, I'm from the Western Cape Department of Agriculture, and I also want to acknowledge two people especially working with me on the project. The one is Karen Germain from the University of KwaZulu-Natal, and then Anne-Marie Klaassen from ED, which is a company based in the Netherlands. You heard Leslie talk about Waterwatch in the previous session. Now, Waterwatch has divided itself into two different businesses now. The one is still called Waterwatch, which is doing the research work, and then they have ED, which is now the operational arm of that. And I'd also like to acknowledge at this stage the funding that we received for this project from our own department, from the Department of Agriculture, Forestry and Fisheries, and also from Hordgrow, the deciduous fruit industry. Now, the question is, why do we need to increase the water use efficiency? First of all, it's one of the things that the Water Act requires us to do. Water should be used more efficiently. And then especially in the Western Cape, it is anticipated that the Western Cape will probably be the province that will be worst affected by climate change in the future. So we need to get our things in place at this stage already to be able to mitigate the possible impacts of climate change. Now, if you look at what we call the water use efficiency, is crop produced per cubic meter of water. In other words, kilogram of crop per cubic meter of water. Now, you can either reduce the water consumption without decrease the yield. That's one way of increasing your water use efficiency. Or you can increase the yield without increasing the water consumption. Now, how do we do that? Currently, there's a couple of solutions and technologies available. For example, soil moisture measurement. You see the graphs there. Stem water potential, where they take the measurements of the actual stem of the water. It depends on how frequently do you get updates from that. And it's a one point only. It's not necessarily representative of the block that irrigation block that you're looking at. If you look at aerial photography like that, you have high spatial detail, but it's also once or twice during the whole irrigation season. So we don't have a continuous source of information available. And then this is where the Fruit Look situation came up. I'll tell you about the name Fruit Look now. This is complementary to current solutions. It's a spatial, quantitative, repetitive, and unbiased satellite-based system that we have in place. And as Leslie pointed out already, it's an energy balance system, not a water balance approach. So we have remote sensing data, and you add value to the pixels that you have, and at the end you have a tool that can provide you with very, very interesting and informative information. Now, the road that we walked with this project was we started off in 2004-07, where we did what we call retrospective studies. We looked at various areas that we have data, field data available, and looked at the water use efficiency of those. And we specifically chose those areas because we had field data to compare it against, what Leslie referred to as well as validation. But all of that was retrospective. We could tell what happened in the past. But then we had to move on to the next stage, is where we can try and provide real-time or in-time information. And then 10-11 we started with grapes, both table and wine grapes. And we had a website where we provided the information through, and at that stage we were looking at grape, we called it Grape Look. So looking at the water use of grapes. And then from the positive results obtained there, we decided to increase the scope and include all other fruits as well. It's not a website anymore, we call it a data portal now, a different way of presenting the data. And then of course we changed the name to Fruit Look. So the website is fruitlook.co.za. Everybody can visit it and look at the information that we have available there. And the whole purpose of this is to demonstrate an operational service providing crop water, nutrient and growth information to fruit and grape farmers in the Western Cape. In the end then to prove water use efficiency, and in the end then also to reduce input costs for the farmers. Now the area we talk about, the Western Cape here, you can see the green areas here, is mostly the fruit producing areas. And the area that we cover with the satellite image is basically on the east of Grabouw, going up to Worcester, the Dorens, and then up to Vredendal area, and then cover the whole area. This is the area covered by the specific satellite image that we use. Now, the Fruit Loop portal can give you parameters updated on a weekly basis on 9 different parameters. It's the actual evapotranspiration for that crop per irrigation block, the evapotranspiration deficit, the crop factor, biomass production, and then if you have your evapotranspiration, you have your biomass, then you have your biomass water use efficiency. You also provide information on the leaf area index and the nitrogen content of the plant and from the top canopy. And we also try to work in forecasts for soil moisture content. So we have the parameters. You can see the change in time for the different weeks and also the change in space that's taking place if you look at that area indicated there, for example. Now, they concentrate also on making use of the infrared spectrum, and the reason for that is we see things that we normally don't see with the eye. If you look at that vineyards and the orchards in that area, they seem to be very similar if you look at it. But as soon as you look at the infrared spectrum, you'll see some of that is under stress. There's higher temperatures in those parts than the rest. Now, we need to find out why is there higher temperature. Normally, it's when the plant, there's either there's disease, or if there's a water deficit, the stomata will close, the temperature will go up, the same as we transpire when we get hot. The same with the plant. So when the stomata close, not enough water for it to transpire, the temperature will go up, and that has been picked up by the infrared spectrum there. You can also see the variation in one irrigation block there. You normally have a little bit of variation in the size because of the roads. Also part of the pixel depends on where the pixel is actually situated. We're working on 20 by 20 meter pixels in this case, but you can see there's some variation in the block in terms of actual water use. Now I'll give you a couple of examples of how the data can be used. For the first farmer, you want to check the performance of your irrigation system. Now he irrigates 65 millimeters per week. The actual evapotranspiration is only 45 millimeters per week. So the irrigation efficiency is about 70%. Now that gives you an indication there's some improvement that can take place. Why is it only 70%? And you can look at the spot image, for example. There you can see there's a very high ET. So is that the indication of a leakage that's taking place there? Or one of the applications. You can also look and try and look at your irrigation planning. Farmers that use a fixed weekly irrigation schedule can evaluate if they're running into a deficit over time or are they actually over-irrigating. You see the crop there, the actual evapotranspiration for the different weeks, 6th of February, 13th, 20th. You can see as you go along there, the actual evapotranspiration that took place. On the bottom is your deficit. If it's red, there's no deficit. So this farmer has some deficit in this week, but with the irrigation, he managed to remove that deficit. The third is if you look at your consultant that play a role in providing scheduling information to the farmers, they can use this information. They have a contract with the farmer. They know all the details of the farmer, the trellising system, the farming objectives, and then they can provide detailed information on look at the different variation in the blocks and go back to the farmer and tell them why is that variation available and what can be done to rectify that. You can also look at your yield and your nitrogen. Here you can see the nitrogen content in the plant. Why did it change so much? For that production of 280 tons per hectare, you can see the variation in nitrogen, and even if you have your fast releasing nitrogen, you can see the variation taking place there, assisting the farmer when to apply the next nitrogen. Also for benchmarking, if you want to evaluate the water use efficiency of crops, this is the X River Valley. All of those is table grapes. This is a Worcester area. Some is water, is stable grapes, and some is wine grapes. So if you look at the areas of red, it will show you the poor performers. So there's room for improvement in the water use efficiency. The yellow ones is the normal ones, and the green ones are the guys really good, doing good with their water use efficiency. So it can also assist us in monitoring and evaluation. Also in terms of carbon sequestration and water footprinting, we don't have time to look at that, but this is, for example, the red graph there shows you the wine grape water use and the carbon sequestration taking place at the end for the 12,000 hectares, and the blue is for the table grapes, 133 hectares in that specific area over that period. We can also use it as an irrigation planner to show you what irrigation will be required. There still needs some work to be done on that to make it really effective. I don't want to spend time on that now. But the most important thing is seeing is believing. We provide this information to farmers, and how can we know it's accurate? How can the farmers trust that? Validation, for example, now. Now you can see there's a cyclonometer taking place, taking measurements of the actual heat fluxes. There you can see this is a continuous monitoring taking place over a daily cycle, and that spot there is where the satellite image is taken. Now it's not on the maximum because that's about 10 o'clock in the morning, and that's where the satellite image is being recorded. But you can see it is on the graph, so we have faith that the actual measurement verify that the satellite recording data is accurate. You can also look at that in terms of your energy balance. Leslie referred to that again. That's the energy balance that they use to determine at the end if you have your reflectance from the crops and from the soil. You can calculate the actual ET, the water use of the plant. And there you can see for this time series, you can see how the actual heat fluxes meet with the red dots. Similar, that's for your Rn, and this is for your G, the energy going into the soil surface, heating up the soil surface again.